Bonjour guys, welcome to my channel. In this video, we're going to do a problem on hydraulics. We're going to calculate the flow rate using Mannings equation. This is a very common FE civil question. If you guys like this video, please give me a big thumbs up. Don't forget to subscribe and let's get started. Oh yeah, everybody now. Okay guys, so we're giving a rectangular channel that is on a slope and the channel is 8 feet wide and the water flow depth is 5 feet. We're giving the Mannings coefficient and we need to calculate the flow rate. So when you're giving the Mannings coefficient in the exam, that is your hint right there. So just go to the reference manual, type that in, and it will take you straight to the equation. So the equation is on page 172. So here we have it here. So just be careful because Q is the flow rate, right? So that's usually the unit for cubic feet per second or cubic meters per second. And V is your velocity. So make sure you pick the right equation. The only difference between this is A, and that's because of the continuity equation. If you guys remember, I mentioned this in the previous videos. Q is equal to V times A when we have an incompressible flow. And that's why we have here the difference between your flow rate and velocity is just the area, because Q is equal to, it's like this, V times the area gives you the flow rate. So another thing to be careful with is K. So if you're dealing with SI units, K is equal to 1. If you have English units, you have 1.486. N is dimensionless. Again, it's a coefficient. Hydraulic radius, we'll go over this in a little bit. The area is in meters squared or feet squared. So make sure all your units are the same. And then the slope is, it's also like dimensionless, feet per feet or meters per meters. And for the hydraulic radius, it's just the area divided by the wetted parameter. So we'll go over that here. It's really important. I think that's the only variable here that can be a little bit tricky to calculate for, but I think everything else is pretty straightforward. So let me write the equation down so we can start plugging the numbers and then solving the problem. So in this case, we have English units, so we're going to use 1.486, and then the Manning is 0.0112. Okay, so the area is, so we were giving the channel is 8 feet wide. So that's the width of your channel, and the depth or the water flow depth is 5 feet. So the area is just going to be 8 feet times 5 feet. Note feet times feet, that gives us feet squared, so that's good. Note guys, I always go back to the units, make sure my units are right. It's really important for the FE exam. Okay, now let's go over the RH. So RH means, so let's do RH here. So they already told us here what RH. So RH is equal to the area over P. Okay, so the area here, we already said it's 8 times 5, right? So we have 8 times 5. Parameter, the parameter or the wetted parameter, let me show you guys how we're going to do that. So if we take this, let's draw this rectangle channel, okay? So let's say I have something like this. This is my rectangular channel. This depth, we said it's 5 feet. That's what was provided to us. And then the width of the channel is 8 feet, right? Okay, so the wetted parameter, it just means like where the water is touching around the whole pipe. And so if this is your rectangular channel, the water depth is 5 feet. So you're going to have 2 of 5 feet, right? And then we have 1 width. So remember, parameter, usually we just do like L plus width plus L plus width. So that would be the parameter of a rectangle. But here we just want the wetted parameter. So that's just going to be 8 feet plus 5 feet plus another 5 feet. So let's do that. 8 plus 5 plus 5. Okay? So this is going to be 40 feet squared over 8 plus 5 plus 5. That gives us 18 feet. So this should give you about 2.22, and this is going to be just feet because feet squared over feet cancels and then you have feet left. Okay, so let's plug in that here, 2.22 feet, and this whole thing is to the power of 2 over 3, and then I have the slope, which is 0.002 to the power of half, and that's it. Plug in your numbers and you should get about 378 cubic feet per second. So the answer is going to be C. Okay guys, so that will be it for today. On the next video, we're going to do a problem on live load reduction. So if you guys want to see more videos, don't forget to subscribe. If you guys like this video, please give me a big thumbs up. Thank you guys for watching, and I will see you soon. À la prochaine. Oh yeah, everybody